Alright, so welcome back. In this video, what we want to do is take everything we've learned about factoring and now apply it to the case where we're asked to solve an equation by factoring. So the very first thing to understand is, what do we actually mean by solving an equation? So I want you to take a look at the problem on the left here versus the problem on the right. And there is obviously a difference between them, and the difference is in the directions. Okay, so the first one says to factor. And we already know how to do this. We're looking for numbers that multiply to this number, that multiply to 12, and that add to -7. And one of those, actually both of those numbers will have to be negative, and the numbers that do that are -3 and -4. So at this point, if the problem just says factor, you stop right there, you're done. Problem on the left side, this one right here, is a slight difference, and that's this word right here. The word says solve. Okay, the other difference is that this equals 0. Over here you can see there's nothing over here, it's just blank. So factor means just break it down like we did and you're done. Here the first step is the exact same. Okay, we factor this the same way, a minus 3 and a minus 4 equals 0. Now here's the difference. When it says solve by factoring, your final answer, when the question says solve, your final answer is supposed to be a equals a number. You're actually supposed to find out what value solves this equation. So real simple example, let me just bracket this off right here. If somebody gives you this equation and says solve for x, you've solved equations like this. Solve for x means subtract 3 from both sides, and now your final answer to this question looks like this: x equals a number. So we're going to do the exact same thing up here. Okay, we want this to equal 0, and there's two ways that could happen. Either a minus 3 could equal 0, okay, or a minus 4 can equal 0. And here's why. If this parentheses equals 0, then we'd have 0 times the other one. And we don't care what the other parentheses is, because anything times 0 is going to equal 0. And likewise with this one. If that parentheses equals 0, then 0 times the other thing, whatever that happens to be, will also equal 0. So let's solve both of these. So we'll add 3 to both sides. We get a equals 3. And over here, when we add 4 to both sides, we would get a equals 4. And this has actually two solutions. Later on we'll talk about the fact that because that's raised to the second power, we knew in advance it was going to have two solutions. Whatever the leading power of x is, or in this case a, that's how many solutions it will have. So it has two solutions, and of course you could plug either of these in to this original and check it, you would get 0. Or you could look, of course, right here. If I plug in 3 right there, 3 minus 3, and then I'd have to plug in 3 to the other one, 3 minus 4. Well, this right here is 0, and 0 times anything is going to equal 0. That's an easy way to check. So what I want you to do now is try to pause the video for these next set of problems and see if you can solve each of these by factoring. All the factoring techniques are ones that we've used before, so there's nothing here that's new. The only difference is now you're not just factoring, you're actually solving as well. Okay, so hopefully you gave those a try, and up here I point out the two initial steps. First, we always have to put these equations in standard form, which means, sorry, that's supposed to be a 288, which means we want to make them equal to 0. So 6n squared minus 12n minus 288. Okay, we'll do the same for the others when we get there. We always put them in standard form, and then secondly, we always see if there's a greatest common factor. That's what GCF means. So if we look at 6, 12, and 288, they do have a greatest common factor, and that would be 6. So what I'm going to do is divide each of these numbers by 6. So 6n squared divided by 6 would just be n squared. Negative 12 divided by 6 is negative 2n. And then negative 288 divided by 6 is negative 48. Okay, we need to keep the 6 in front the whole time. It's not going to affect the answer, but it needs to be there so that if we were to multiply it back out, we'd get back where we started. So now what are we looking for? We're looking for numbers that multiply to negative 48. So one would have to be positive, one would have to be negative. And again, n, we're putting the n's there because that's going to give us the n squared. Multiply to negative 48, add to negative 2, and I believe that turns out to be minus 8 and plus 6. So now how do we solve this? Basically we need each of these parentheses to be 0. And what n value makes the first one 0? That would be n equals negative 6. All that we're doing there is setting this equal to 0 and then subtracting, and that's where we get this number from. And by similar reasoning, the second parentheses will give us n equals 8. So those are our two solutions, and we'll pick up with the next one as well. So number 2, first thing is we need to put it in standard form, so let's do that. So we will subtract the 3r from both sides. and put this in standard form. So we have 2r squared minus 3r minus 20. Second step is to look for a greatest common factor, but in this case there is none because 2, 3, and 20 don't have any number in common that could be factor of all of them. So in this case we want to use the swing method because the number in front, the a term, and by the a term I mean when we write something in standard form, a is the number in front of the squared term. In this case a is 2. So that means we'll swing it over here. So we'll have r squared minus 3r, and then 2 times negative 20 is negative 40. So we're looking for numbers that multiply to negative 40, and the only things that multiply to a negative are 1 positive times 1 negative. And then also that add to negative 3, and that's going to be negative 8 times 5 would be negative 40, and negative 8 plus 5 would be negative 3. Okay, then the swing method, remember that the 2 went over here, which means it's still in the 40, which means it's still in each of these numbers, so we need to get it out by swinging it in front when we can't simplify it. So let's double check. So here, of course, we could simplify 8 over 2 to get 4. In this case, we can't, so we'll swing it in front. So we'll get 2r plus 5. And now we need to solve it. So right here, this parentheses would equal 0 when r is 4. And this parentheses, it's a little bit hard to do that off the top of our head, but I'll show you a shortcut in just a sec. So let's set that parentheses equal to 0 because that's going to tell us what the solution is. So when we divide this by 2, we would get r equals 5 over 2. And I told you I'd show you a shortcut. Here's the shortcut. Actually, I'm sorry, that should be a negative 5 over 2. So negative right here is the shortcut. If you look at this parentheses right here, you could actually just look directly there and notice that if I plugged in negative 5 over 2 right there, I would get a 0 out of that. Okay, so that's how we solve each of those by factoring. We factored it, and then we set each parentheses equal to 0 and solve for r. All right, last two, number 3 and number 4. These are a little bit different because they only have 2 terms. I should say most of these have 3 terms. So again, same rules. We always put our equations in standard form. These are both already in standard form because they're equal to 0. And then the other thing is we always look for a greatest common factor. And if you look at these numbers, 5r squared and 35r, they both have a 5 that goes into them, and they also both have an r that goes into them. So we need to factor that out. Okay, then we'll divide by 5r from both sides. Now, one thing I want to point out: if this were just a 5, we wouldn't need to include it in our answer because it has a variable there. I don't want to confuse you. What I mean is, if you look at the previous problem right here, this 6 in front had no impact on our answer because there's no way that 6 could equal 0. There is a way that 5r could equal 0 though, so we just need to keep that in mind when we're solving this. Okay, so how do we get what's inside? Well, 5r squared divided by 5r would just be r. 35r divided by 5r is going to be 7. So again, we're going to have 2 solutions. One of them will come from that front part equaling 0, and the other will come from r minus 7 equaling 0. So we add 7 to both sides, we would get r equals 7 as our first answer, and then when we divide by 5, we would get r equals 0 as our second answer. And of course, we could test those by plugging them back in, and we would find out that they do in fact work. All right, last one is number 4. First step is standard, put it in standard form, it's already there. Second step is look for a common factor, and in this case the number 2 goes into both of these. So if we divide each term by 2 there, we would get x squared minus, and then 98 divided by 2 is 49. Alright, so there's no way, again, there's no variable with the 2 right there. It's not like that last problem we just did. That was not just the number 5, it was 5r, and so that's why we had to set that equal to 0. But in this case, the 2, there's no way to make 2 equal to 0, so we don't have to worry about that. We'll just keep it there to show that it was part of our original answer, but we're not going to do anything with it. Okay, now you may or may not recognize this, but that's something called a difference of squares there. There's no x term there. So the way that this works is we need numbers that multiply to negative 49. One will be positive, one will be negative, and then add to 0. Or another way of saying that is a difference of squares means that you squared something to get the x squared. You squared x, so x times x. And you also squared something to get the 49. You squared 7. And then one of these has to be plus and one of them has to be minus in order to make it work out so that the middle terms cancel out. Okay, so now all we need to do is set each of these equal to 0, and the first one will be made 0 if we plug in negative 7 there, and the other one will be made 0 if we plug in positive 7 right there. So that's just a brief overview of how to solve by factoring. None of the factoring techniques that we use were new there. The only difference is that we want to be familiar with the difference between when it just says factor versus when it says solve by factoring. When it says solve by factoring, our final answer to the question should look like this. It should say x equals usually two numbers, as in this case.